I'm just really going to be speaking about my master's thesis research today, and what I've really focused on is sort of the environmental side of archaeology, and what I focus on specifically is the Native American Southeast, right, really in Florida. So that's a very long time frame here in Florida. I'm focusing on a specific period, that's the middle to late woodland period. I'll talk about that in just a minute. So I guess I'll go ahead and just do a general run through of southeastern prehistory. A lot of you probably already know what I'm about to do, so you can take like a 2-minute nap or something if you want to, but just going to give a really basic run through of some general time periods in Florida as sort of a precursor, and I'm also going to start with some basic archaeology of the Crystal River, how it started, and what we've done there recently, and how we sort of pulled things out of the ground there. So, 4 really broad time periods in the southeast, and these have some variability in Florida, but these pretty much ring true for Florida as well. You have the Paleo-Indian period, about 14,000 years ago. Then you get the Archaic right around 10,000, and the Archaic is obviously an incredibly long time period. Then the Woodland period, which the sort of middle and late half of this period is what I'm focusing on for my research, and the Mississippian period. And these all exist in Florida, but there's a lot of nuance and variation in Florida that you don't really see in the rest of the Southeast. And some of these periods, especially these sort of last 3 periods here, and we'll talk about that in just a minute. So a couple of key things that happened during the Paleo-Indian period. Obviously, this is the sort of marks the transition between Pleistocene to Holocene. Okay, and what we mean by Pleistocene is the end of the last ice age. We're technically still in an ice age. The Holocene is an ice age, but we're just sort of in a less severe part of it. Anytime there's ice on the poles, it's technically an ice age. But the Paleo-Indian period marks the transition where you have massive amounts of water locked up in these polar ice caps. So we essentially had much lower sea level and a much longer coastline. This is sort of marking where the coastline was 10,000 years ago, then about 8,000, about 6, and of course around 5,000 years ago during the Archaic is when we have sort of the arrival of modern environmental conditions. So not only do you have modern sea level and these sorts of things, but you start to have flora and fauna that kind of mimic what we have today as well. So, Paleo-Indian sites, this is if anyone got any of our Florida Archaeology Month posters last year, that's it. That's the incredible little salt spring, and occupations were a little bit more sparse in the Paleo-Indian period. People started to get more sedentary and were living in closer quarters as time went on. So we really get a lot of projectile points from this time period, but a lot of stuff really doesn't survive. So there's not a whole ton we have from the Paleo-Indian period, but at least to me it's a fascinating period of Florida's prehistory. The Archaic period, a couple of key things began to change in the Archaic. We've obviously talked about the environmental stuff, but as an archaeologist and anthropologist, of course, I'm interested in the cultural side of things. So what people started to do is they started to sort of more densely settle on the coastline here in Florida, the modern coastline. And it's really the beginning of a couple of key things. One is intensive fishing. Fishing both for vertebrate species like actual fish, but also for shellfish. And these just sort of show some examples of what are called shell rings in Florida. And there's a lot of debate on what they actually mean. Are they just garbage piles, or are they purposefully, sort of created as some sort of extension of symbolic behavior, right? So that's a big debate in Florida, but you get people who are living together in closer quarters, not quite as close as later time periods, but you get the sort of formation of semi-sedentary life, which means people are beginning to start living in closer quarters with one another, and they're harvesting these shellfish and things a little bit more intensively. And then you get the invention of pottery in the really, really late, but it's in the late Archaic.
When is that, like year?
What's that?
Like when?
The Archaic period, the pottery, the Archaic period extends from about 10,000 years ago to about 3,000. But these developments are sort of late. Actually, there's a lot of evidence that suggests that fishing has been going on longer than people thought. People thought that when the sea levels were rapidly changing before 5,000 years ago, there weren't really stable resources and things like this for people to exploit, but a lot of people, sort of like Mike Russo and others, would argue that might not actually be the case, that people might have been living on the coast and sort of fishing predictive areas for a really long time. And the pottery doesn't come until about 4,000 years ago. So it's kind of a development in the late Archaic. So, all right, the woodland period. This really sort of marks a really big transition in general southeastern prehistory, because I think we all know what this thing is here on the left. That's a big burial mound. This is or not a burial mound. Excuse me. It's a what some people call temple mounds, but it's a Native American mound. So. This is actually Kolomoki in Georgia, but we have similar ones in Florida, and there's one at the site that I work at as well. There are several large mounds, and they started to construct these things called mound complexes. They're really, really angular features, considered monumental architecture. So this is a really important period. People also are starting to engage in what we call like sedentary lifestyle, right, where people are living in the same spot with one another. They're really settling down in one spot, and they're not moving seasonally nearly as much as they used to. So another key development during the woodland is pottery. Although we have some in the Archaic, became much more sort of elaborated on, and this is when you get some really nice, fancy stuff. This is a Swift Creek pottery shred right here, and that's sort of a middle woodland style of pottery, but you get these really intricate designs and things like that. And in Florida, this is an important period because this is also when people were living more heavily on the coast and were even more intensively exploiting coastal resources and shellfish and things like this, and fish. And this is really the side that I'm interested in. So we'll get to more of that later, but really important time frame. Okay, then we have the Mississippian period. So some of the same things kind of continued during the woodland into the Mississippian, and you can obviously see mounds in some places got really extreme and really elaborate. This is Cahokia in Illinois. This is Monk's Mound. It is the largest pre-Columbian structure north of Mexico in the Americas. So this is really when you start to get things like a lot of social hierarchy, right? Social inequality, things like this. You get sort of the development of almost like sort of class and a lot, like I said, social hierarchy. We don't need to get more into that, but what also, at least in the interior heartland of the Southeast, happen is we get farming. Okay, this is corn right here, and this is sort of a mainstay in places further north than Florida, but people were doing the same things in Florida, but they were doing it really without any agriculture at all. That's kind of a false thing that a lot of people that believe for a long time, was that you had to have agriculture to have these complex societies, right? You had to have agriculture as a reliable resource base, so that you could sort of create economies and then feed a lot of people with this sort of predictive resource. But in Florida, people were doing these same things, maintaining these sort of political hierarchies, social stratification, and building these large mounds, directing labor forces, pretty much while still just fishing and gathering shellfish and wild resources and things like this. So Florida's a bit of an anomaly, especially in areas further south, but there are really examples of this all over the coast. There's only really a small part of Florida where agriculture ever hit in prehistory, and that's the Florida Panhandle, and just a couple of sparse areas. We really didn't have that on the peninsula at all. So yes.
About how many people have you talked about being in Florida at that time?
That's a really hard thing to try to extrapolate. You know, some of the early Spanish mission accounts, that's all that we really have to go on in a lot of circumstances is, you know, up in the hundreds of thousands in just South Florida alone. And so we know that there were a lot of things happening, like the Calusa. Has anybody heard of the Calusa of Southwest Florida? Like Naples area, Charlotte Harbor, all those areas. There's evidence of like tributary demand, so they were sort of controlling people that weren't living in the direct area. They had, you know, sort of, they were demanding tribute from places over almost as far as the Florida Keys and things like that. So, you know, there was a lot of movement. There were economies going on at this time, and you know, just really some of the things that we see today. So that we you know in ourselves. So not necessarily as removed as we might think we are. But so now we'll get into sort of this. These are just general things that are good to get into. And I already kind of talked about this, sort of why Florida is weird, but in a good way, and why I love doing research here, because it's really kind of, you know, an anomalous place. Is when you talk about, you know, pre-Columbian sort of complex society and this ability to maintain and support large populations without agriculture, and just, you know, sort of on the complexity of their fishing strategies and things like that. So that's really what I've gotten into personally. And Crystal River, where I work, is a very good example of this. So this is an introduction to Crystal River. This is Mound A, right on the water here. It's a mound complex, so there's several mounds at the site. I'll get into that in a little bit, but this is where it's located. So you can see kind of, it's about an hour and a half north of Tampa and Pinellas County, St. Pete over here. So it's right in that sort of Nature Coast, Big Bend area, and it encapsulates the middle to late woodland period. Just it's really its early rise to fame was because of this guy C.B. Moore and his excavations there. Does anybody know C.B. Moore? I'm sure no. Okay, this Kevin knows. C.B. Moore was, okay, I like the stuff he found. Most archaeologists do, but he was pretty much kind of a glorified looter, a grave robber, right? He went around on his little boat, the Gopher, and he went to all these sites along the Florida Gulf Coast, and he pretty much was just digging in burial mounds looking for the good stuff, right? And this was his first visit to Crystal River was in 1903. He had a couple more. I believe the next one was in 1905, and his final one was in 1917. But what he pulled out of some of the burials, I believe he excavated as many as 400 burials, most of which are in the Smithsonian right now. But you know, unfortunately, we don't have a lot of context from these items, and it was done obviously in kind of poor form. But what he did find in some of these burials are very exotic artifacts, right? So things that aren't being produced locally, they're being traded. Some of the stuff that we found is copper, right? And copper, the only real sources that we think that they might have come from are all the way up here in the Great Lakes. And this is part of something called the Hopewell interaction sphere. It's sort of something that develops during the kind of the early woodland, and then sort of more so in the middle woodland period, so around 0 AD or so, really sort of takes off. But what it is it's not really a single group of people that are living together. It's sort of like a ceremonial interaction sphere, right? It's people joining together in these certain spots, trading goods from an enormity of areas all across the United States. You can see we find obsidian coming all the way from out west, and then shells coming all the way from Crystal River that are being found in places like Ohio. So we know people are really interacting from really broad spatial scales here. And so we found mica in some barrels, and even in the midden context that we excavate. I'll get into what a midden is in a little bit, but we get some mica as well that's coming from the Appalachian Mountains up here. So this was sort of Crystal River's really, early claim to fame, because it's the southernmost extent of this Hopewell interaction sphere. So this guy, although not the best, he didn't really do great archaeology there. He sort of got Crystal River's the lore of Crystal River rolling, really, if you will. So. All right, and further on, we got some excavations from a guy named Ripley Pullen. He did a lot of archaeology in Florida. His sort of run there was during the 50s and 60s, and Ripley excavated all over the state. The only thing about it definitely, signified a significant improvement from C.B. Moore's sort of grave robbing, but Ripley Pullen, unfortunately, had a tendency to not record a lot of his stuff very well, a lot of his excavations, so he excavated at the site, but we don't really know what he did other than his publications, which weren't very well distributed or widely disseminated. So there was still a lot of mystery at Crystal River until we finally were able to get out there, because he just didn't publish anything very well, and we didn't have access to, he didn't record things very well. We didn't have access to his records. So Dr. Brent Wiseman, who's at USF, sort of went in there and did some work during the mid-90s, and he compiled sort of a really great site history there of who was there, when they were there, where excavations might be, where we can rediscover things and sort of recontextualize things that have been excavated out of place by these earlier people. And then you have this kind of long acronym, PREVOP, right? But that's the Crystal River Early Village Archaeological Project, and it's led by my advisor, and as well as Dr. Brent Wiseman and Dr. Victor Thompson. My advisor is Dr. Tom Placan, and they all sort of teamed up and created this research project that has spanned about 3 years now. And we just did our last excavations, not this last summer, but the summer before that. And what we started out doing was they did some coring there. They did some GPR survey at the site to try to locate some features that we knew were there, but they didn't really understand exactly where they were. So they used things like GPR survey, another survey called, or another testing method called soil resistivity. And it alerted them to where the midden was, and a midden, please, once I go to sleep if I'm sort of explaining something you already know, but a midden is different from a mound. Because a midden, according to some people, is just a trash pile, and that's really what it seems to be. It's refuse remains, right? There's a lot of shellfish, there are a lot of bones in there, broken pieces of pottery, broken projectile points, all these sorts of things, and a lot of times they're sort of scattered in sort of like a ring-like fashion on either the outskirt of a site or in a sort of pattern that you can delineate in the site. They're not really random trash pits. They sort of form these nice long rings, and these are really what you want to look for as an archaeologist, because they tell you about what people were eating, what type of pottery they were making, what sort of lithics they were producing. It tells you really a ton about life in the past. So we wanted to really locate this feature, this midden that we knew was there, but once again we didn't have the greatest records from these early excavations, so we didn't know where they were. So finally it was located with these with GPR survey and things like this, and we excavated a total of 4 trenches in a unit, and that's each trench was 1 by 2 meters long, and except one trench that was 1 by 4 meters long. So we removed a lot of dirt, but any time or any amount of time that you spend in the field, you can go ahead and multiply that by 4, and that's the amount of time that you're going to spend in the lab processing the stuff, writing it up, doing all these sort of extra field analysis stuff, right? And unfortunately, there was some damage. This is Mound A. There's some damage done. This is what appears to be the east side where the ramp used to be, and you can see that's been bulldozed for a trailer park that went up there in the 1960s. Florida doesn't have the best, or the United States in general doesn't have the best record before the 60s with sort of preserving pre-Columbian monuments. So those things are unfortunate, but we've been able to get out there and do some good work, so it's not all bad, right?
So
Yes.
Perhaps not everyone knows what GPR is from.
Okay, I'm sorry about that. No, thank you. Thank you for forcing me to explain that. It's ground penetrating radar, and Kevin, jump in anytime you want. And so you want to explain because he's really. I mean, I didn't do the GPR. I do something I'll get into later. So if you want to take
very quickly, GPR, the same type of radar that airplanes use to sort of find out where things are in the sky. It's basically taking that antenna, propagating the radar waves into the ground. You have different antenna strengths, so you might do 250 megahertz, 400 megahertz. It depends on what you're trying to find and how deep you're trying to find it. And all that it is really, let's say this is your antenna, you have different strata of soil that are different, let's say some is like clay, some is sugar sand. The radar wave is going to move faster through some, not as fast through others. And things that aren't supposed to be there, you tell this to the machine, things that aren't supposed to be there come up as anomalies, and it will register with the antenna. So as you move an antenna along, it's registering what's there, what it should be there, and what's not, what it doesn't expect to see, and that's an anomaly. And so that's what Trevor was talking about. In the mound, you can say, I expect to see this, show me what's not expected. And that's where they're finding these sites. In a nutshell.
How do you spell that minimum that he talked about, the little that circular thing? It's not a mile.
MIDDEN. All right.
Yeah.
Okay, and this is just sort of a basic diagram. Not going to spend too much time on this of where we placed our test units. So you can see this is a just sort of a topo map, a topographic map of the site. This is that big mound I just showed you, Mound A. This is Mound H. This is the plaza in here, and this is where they identify the midden with GPR and resistivity in these things. So we re-identified a spot over here. This is the one that we put in 2 summers ago. We also put in another one right here, and these were the products of the first years of work. So they all went into the midden, and this is the way it's been identified. Sort of this ring moving from northwest to southeast along sort of right in front of Mound A across that axis in the site. So, okay. Also important to note though, it's not just Crystal River that we're interested in. There's actually a pre-Columbian mound complex just right across the river. You can't really see it. Crystal River's right about here. This is the actual Crystal River itself. And this is Roberts Island, and this is a mound complex that develops really late and sort of the site's history. This is towards the end of the woodland period, and there's another mound complex right here. As you can see, there's a mound. The red indicates, we didn't do any test units here, we did little 50 by 50 centimeter squares when we excavated, and those are called shovel tests, and that's just sort of where we did our excavation there. And the occupation stops at Crystal River, and it moves over to Roberts Island. We're not really sure why they did that, why this happened. I'm trying to investigate to see if it's a resource thing right now, but more on that later. Alright. This is just kind of showing you what a basic profile looks. The midden is very deep. There's the Crystal River was actually occupied for close to 1,000 years. So it was really, we don't know exactly when people started living there long term, if they even did live there long term, but we know that there are a lot of deposits made in here. The midden is really expansive, so we can at least say that there was intensive harvesting, and this is what we call a profile looks like in one of our test units. This is unit 1, or this is trench 1, units 1 and 2, and you can see the midden's pretty deep. At some places it's about 6 feet deep. Some probably deeper. Once you get to the water table, you can't really dig anymore. So, lot of deposits over a long period of time. All right, just going to go briefly into some sort of theoretical context that sort of belies my study. What I'm looking at specifically, I'm looking at the resource base, the marine resource base, what they were harvesting. How much of it were they harvesting, and most importantly, were they harvesting enough to impact the local ecosystem? That's sort of a question that's really at the forefront of modern concern with these, you know, ecosystem collapse that we have going on right now around the world, and where people, so in efforts to sort of restore our ecosystems, management agencies are trying to get an idea of what ecosystems look like before humans impacted them significantly. And we know that we've been doing this for a couple hundred years now, and only until recently have people thought, well, you know, Native Americans have been living here for a long time as well. They were harvesting resources really intensively. So what does that footprint look like on the ecosystem? Did they overharvest? And what is a natural ecosystem supposed to look like? Because we're probably not getting it. If you're looking at an ecosystem that you only have 50 years of data on, well, it's likely been sort of, excuse my French, screwed up for a long time, for a lot longer than 50 years. So you don't really have an idea of what that ecosystem is supposed to look like. And I'm also just, shame on me, but I'm also just interested to see if this was happening. If they were, to what extent did they modify their landscape? What does the full human footprint look like at Crystal River? And I'm really interested in how humans and environments modify one another. This is really a kind of a big debate in Florida. You have one side that is almost taken a sort of human behavioral ecology approach, which kind of assumes that social change and change in societies in prehistoric Florida are a process or are a product of sort of environmental adaptation, right? You always hear that word, adapting to the environment. Other people like Ken Sassman and a few others have come along and really said, no, it's really more social interaction. People are, you know, it's sort of historical interactions between humans that are unique, and that's the real cause of culture change in prehistoric Florida. And so as a sort of a correlate, people debate a lot on what these middens actually mean. And are they just garbage like this, or are they trash that is used for some sort of symbolic purpose? Like this Mount Trashmore in Virginia right here. So there's a big debate on that in Florida. I don't necessarily view that it has to be as polarizing as some people think it is. I'm not sure that's how Native Americans even conceptualize things, being either one or the other. It's either trash or it's not. But this sort of approach that I'm taking is get fancy. It's an anthropocentric approach. I'm interested in the things that people did, and I really am sort of taking an approach that puts humans as the primary modifiers of environments, not necessarily where they're reacting and responding to direct environmental stress imposed upon them, but I'm really focusing on how humans modified their environment to go about their life and construct life ways. So that's really my theoretical approach to this research. So I want to look at these things, these harvesting impacts, but how am I going to do it? Some things, you know, we do now that are impacting ecosystems are not going to be relevant to pre-Columbian Florida, right? I mean, propeller scars on seagrass beds. People weren't using boats back then, right? So I'm not going to focus on that. But what people were doing, they were fishing for a very long time, and they were harvesting shellfish. So really, the first part of my analysis is something called fishing down the food web. It's something that I'm looking at, and it's this modern phenomenon that we have going on right now in global fisheries. And what it is everyone, you know, I'm sure knows what the food web is. It's pretty much, you know, the food chain, the food pyramid. So in the ocean, you have things like detritus and microbes and things like this that make up the first trophic level, and then you have fish that feed on plants that make up trophic level number 2, and on the food chain up you go until you get to sharks and things that eat only other fish. That's a level 5 trophic level. So what's happening is these high-level these high-level consumers like sharks and all the fish we love to eat, big tuna, big snapper, and things like this, they all take a really long time to grow and reproduce, right? So it's not that hard to overfish an entire population and not give them time to reproduce. So what happens is you end up shifting down the food web and focusing on smaller species. This is happening in a lot of fisheries where we're exhausting these sort of top-level predators up here, And then we are, resorting to more smaller fish like sardines for these global fisheries, and they have to fish these smaller, lower food webs until they can allow the top ones to regenerate. So people initially thought this was something that only happened with a huge amount of fish that we eat on a daily basis, but actually there's recently been a lot of good case studies done by archaeologists that show that this is a phenomenon that's been existing in prehistory as well, especially with people who had these big, sort of complex societies with monumental architecture, had a lot of people living there, they had to feed a lot of people, and there are examples of this in the historic period, but now we're getting to it in the prehistoric period. They could be evident at Crystal River, we don't know yet, so kind of why I'm doing this. Another thing, though, is something called life history, and molluscan life history is just mollusks, so shellfish. And what life history is it's really just sort of an impact on some sort of evolutionary characteristic of a species. So when you overharvest certain species like gastropods, you can cause the entire species to not, or the entire population in one area to not grow to its full potential. What eventually starts to happen is they don't grow to meet that certain size they used to anymore. And that's an evolutionary impact of human overharvesting. And this is something that I'm going to be looking at, particularly with gastropods, because they take a lot longer to grow and develop than like an oyster. Pretty hard to stress oysters a lot of times because they reproduce really quickly. These gastropods, not so much. So this is the kind of stuff I'm going to be looking at. Alright, why I think personally the woodland period serves as a really good time frame to test this idea, especially at Crystal River, is because it's sort of right in a transition between not so intensive harvesting to where you can look at what a non-impacted ecosystem looks like with the earlier archaic period, but then the first time that it's possibly encountered with these sort of intensive sedentary environments like at Crystal River. So this is sort of an intermediate period between that change that I just mentioned, and it could be a really sort of interesting spot to look at when impacts were first had, and also what an unimpacted ecosystem is supposed to look like. And also what's interesting as well is that at Crystal River we also know that because people were building these mounds, they weren't building it out of dirt necessarily like they were in other areas. Most of the mounds at Crystal River are made of shell. And these mounds are not really just made of garbage. It's fairly obvious now with a lot of data that we have back that people were amassing large quantities of shell just for the purpose of building monumental architecture. And don't want to jump on my advisor, or jump ahead of my advisor here, but he's communicated to me that a lot of our isotope data on seasonal collection, which just determines what season people were harvesting shellfish in, it looks like they're harvesting them to eat them, and they're in the middens all year round, but they're only constructing the mounds at very specific times of year. So these things are clearly, to me at least, clearly social and symbolic, and they're collecting shellfish not just to eat them, but also to construct these sort of social earthworks that are going on. So not only do you have a harvesting impact from people that are just trying to eat, but you also have it from these sort of these demands for monumental architecture. So, all right, especially with the life history, there hasn't been so much critique of the trophic level thing that I got into, but this molluscan life history has been sort of critiqued by a shell guru in Florida archaeology named Cheryl Clausen, and she's got a lot of really valid points. She, will say, okay, well, you're seeing these impacts maybe, but a lot of times predation from other animals is more intense than that of humans. You have these birds. This is actually called an oyster catcher. I don't know if it's eating an oyster there, but that's essentially what they do. And then you have sea otters eating abalone, all types of non-human animals that also prey on shellfish. So is the trend that I'm seeing, if I do see one, is it a natural trend, or is it actually one that humans caused? It's a really valid concern. And you also have not just predation from non-humans, but you have environmental events. Changes in temperature, rapid changes in salinity, all of these things can affect the size of organisms on an entire ecosystem level. So with that in mind, my response to that is she really gave that critique in the early 2000s. It's still very valid, but a lot of recent case studies have addressed things that are only correlated with human behavior. Like in the Caribbean, there's actually people were causing entire populations to change. I'm talking about pre-Columbian Caribbean, so Native Americans. They were harvesting this one size of not crown conch. What's the other one we have in Florida? They were harvesting a conch species, regardless, that fighting conch. Excuse me, that's the one. And they were harvesting this specific size of fighting conch just for the tools that they made. They made these shell hammers, and they were harvesting this one size so intensively that they actually caused the entire structure of the population to change, of the conch population. So that's a really big harvesting impact. And there was a lot of evidence of this happening in fisheries in Maine, and also in places like the California Santa Barbara Channel. Abalone used to be huge in the initial middens, and in the California Santa Barbara Channel. And over 7,000 years, people have continually harvested them. Native Americans have continually harvested them to the extent where they're much smaller and they don't even get anywhere near the size that they used to be. So, and this is happening independent of other species that were not harvested by humans. So, it's almost 100% you can say that is a human-triggered response in these shellfish. And also, that's why I chose to use multiple lines of evidence. If I was just saying, okay, I'm just looking at the trophic level, that's going to be a little dicey on the interpretive part. But if I combine it with, okay, are they stressing the vertebrate aspect, the fish part of the ecosystem, and the shellfish, and we get some environmental data back, reconstructing past environments, using these multiple lines of evidence, I think builds a much better case. So that's what I'm trying to do here. And also, which I'll get into in just a second, we have a pretty high degree of midden resolution. And what I mean by midden resolution is that, so we have these deposits that expand for a really long time frame. It's over 1,000 years right here. So what does it mean? What does it mean when you're digging in this level at about 15 centimeters? What time period are you in? What time period are you in when you're down here at about 80? So what my advisor has done is he took a lot of samples from different spots in the midden in different areas and different units, and we've submitted the radiocarbon dates, and we submitted, I believe, somewhere around 60. We were able to use about 40 of them, but they've allowed us to get significant understanding and sort of resolution on what every layer in here means and what time period that corresponds to. So when we're digging in this level, we know we're in a time frame of about 570 to about 700 AD or so. So, all right. So how am I going to do this stuff? All right. Well, I'm going to have to. What I've been doing recently. Like I told you, it's pretty excruciating in the lab after you pull all this stuff out of the earth, out of the middens. So I've spent probably hundreds and hundreds, if not over 1,000 hours probably already, just counting these things, just counting it. So because what we don't get whole fish in these middens, and we don't even get whole shellfish. It's all broken pieces of stuff. So how do I have any idea of how much they were actually eating, how much meat they were getting off of these things, and how much each species contributed to the diet? It's really kind of a pain sometimes. So we have these terms that we use. They all contribute in different ways. One thing is called NISP, and that's just the number of identified specimens. That's, you identify a species, how many fragments of that species do you have? That can sort of tell you something about how they all give you different levels of analysis, but it can tell you something about how many species were harvested, how much of that species was harvested, but it doesn't really allow you to get very specific. That's why we have these things like MNI, which is a minimum number of individuals. So say you have 20,000 fragments of oyster, and you have no idea how many whole ones that actually accounts for. What you can do, and what we've been doing, is you look at something called a non-recurring element, or something that's really sort of a highly identifiable thing on the shell, and we have the umbo, the hinge, right where the hinge is. So if you say, okay, each oyster has 2 hinges, you count up all the hinges and just divide them in half. So you say, okay, at least we know we had 7,000 total, so we know we at least had 3,500 oysters in this specific time frame, right? And then biomass is something that allows us to calculate the amount of meat weight on each specimen. So the vertebrates, this is a little bit more difficult. What you can use sometimes is a scaling relationship. So you say, okay, I've got, I don't know if this is correct, but you can say something like a deer metatarsal, right? And you say, okay, at a certain size of metatarsal, you have the deer is typically this much in weight or something like that. You can use these sort of things to calculate and extrapolate biomass. And there's similar things with shell weight and doing this with shellfish species. So this is how I'm going to look at all of it. And the mean trophic level is calculated simply by sort of adding, because each species has a trophic level. They vary from 1 to 5, as we talked about. So a shark is a really high level consumer, so they're almost a 5. They're like a 4.7. And then an oyster is a suspension feeder, so those are like a 2, right? So we calculate, we bring that trophic level in the equation with biomass and MNI and these other things, and it allows us to get an idea of sort of what food web they were targeting at a certain time period. So that's really what I'm looking at. All right, how do they do it? I'm just going to go briefly into fishing technology. So this is pretty cool. This is actually, these are real artifacts. This one is from, I believe, Key Marco. That is a whelk, almost like a whelk reel. What it is, you see it's got that line wrapped around it like that. It's a really rare find because this stuff never preserves. It's organic, right? So you have to have really unique conditions. It's either got to be in a wet environment or it's got to be isolated from oxygen somehow. So this is a really rare find. People were using things like line and hook and line. We find bone fish hooks a lot, actually, pre-Columbian bone fish hooks, and things like nets. All right, these we not only do we find nets sometimes, but what we find more often are these things called net gauges. Excuse me, and they are these sort of I don't know how to describe them. They're these little squares cut out of whelk shells and other types of shells that you can place in between fibers, so you can make the size of your net, the size of the hole in your net, identical every time. So they were using a lot of net fishing, and they were also doing, which I know a lot of us wish we could do, tidal traps and fishing weirs, right? So that's pretty much, you get into an intertidal area, when the tide comes in, you set up all your traps, you enclose the mouth of a river or something like that, and when the tide moves out, all those fish are stuck in there, you go in there and pick up everything pretty much after that. So that's
Poor fish.
poor fish, right? But it'd be pretty good eating, right? All right, and this is what I was talking about, the midden resolution thing. We sort of had a general idea based on some radiocarbon dates that were done several years back, but they really didn't compare in accuracy to this recent study that my advisor's just done. And early radiocarbon dates suggested as far back as from the initial occupation as being about 300 BC. But that doesn't mean that these dates don't necessarily mean that people weren't there at this time period, but what this program, it's called OxCal 4.2, and it's a statistical modeling program, and what it allows you to do is it allows you to sort of organize these deposits in a way that allows you it lets you see sort of broad time phases in these middens and things like this. So phase 1 is AD 155 to 211, and we have 4 separate phases. Phase 2 is the one that I'm most interested in, because what we also looked at, we didn't just look at the radiocarbon dates, we looked at the rate of accumulation. We looked at how fast these shellfish were being deposited, to use that as sort of almost a proxy to measure how intensive people were harvesting things. So we know, okay, it's the harvesting intensity is not, you know, that much here, but here is only a time of 100 years or so, but you have a huge amount of shell being deposited in that time frame. That's what we call like an accumulation rate, and that's what we're sort of looking for in this phasing. And phase 2 is not only is it the broadest time period, but it's the largest accumulation of shell vertically in the midden, but it's also has the highest accumulation rate. So this is the time, if I'm going to see a harvesting impact, I expect it to start now, because not only were midden deposits being made at this time, but people started making the social monuments, these big mounds, during phase 2. In phase 1, there's really not much going on at Crystal River. There's some people, there are some small-scale monuments being built, a couple of burial mounds, I believe, but there's really not that big monumental architecture that you see in phase 2 in these later time periods. So I'm really interested in phase 2 through 4, comparing phase 2 through 4 with phase 1 to see if that's when, you know, initial stress possibly happened because of pre-Columbian harvesting of resources. So what I did, the species that I actually chose for the shell measurement was a gastropod called crown conch, as Florida crown conch. And the reason I chose this is because, as we talked about earlier, bivalves like oysters and clams, these things that have 2 shells, they reproduce and regenerate very rapidly. But these crown conch, these gastropods, which gastropods are basically sea snails, and they take a lot longer time to reproduce. They don't disperse quite as widely, so it's easier to stress a population, right? So if I was going to see a size impact, I figured this would be a good species to look at, because not only is it a good indicator, but we have a lot of it in the middens. So I chose crown conch, but what I had to do, I wasn't able to use length, because people were they weren't only harvesting the crown conch for food, they were using them as tools. That's by far the most widespread tool we have. What we have is sort of you'll have the conch and you'll have 2 holes. You'll have a hole on each side, and you'll see that it's been bashed significantly on the end. And that lets you know that's pretty much a conch hammer at that point. So you obviously can't measure the length of something that has been sort of battered down by human behavior. So what I did is I compared width and length in this little stats diagram, and made sure that width is a good producer of overall body size, or width is a good indicator of overall body size. So found out with this test that it is, decided to go a little further. And these are the measurements that I'm talking about. So this is maximum width, and this is these are the crown conch. And where I could, I measured maximum length, but when you have the tools, often these are blunted as much as half of their distance because of the hammering and things like that. So this is really what I focused on for the life history. So to me, I got a very interesting thing happening here. It's pretty much the exact opposite of what I expected to happen, right? So these are phases. This is phase 1. And these are phases 2 through 4. So these are the later time periods right here. And what this graph is showing is that there's a significant difference. There's an increase in size between phase 1 and phases 2 through 4. If harvesting intensity increases in phases 2 and 4, why am I seeing an increase in size? I would expect that if I was going to see an impact, they would decrease in size through time, right? So this was a little confusing to me, but when I looked at a student he measured about 600 oysters with the same time periods that I did, he found the same exact correlation with the oysters. You can see they start out a little small down here, and they jump up as much as 10, as much as 13 millimeters higher, more in size than phase 1. So that's one element of the analysis. There are the results. What I also got, I haven't gotten the vertebrate data back to do the trophic level test yet. Trophic level analysis, excuse me. Because what I need to do is I need to combine vertebrates and invertebrates into this same analysis to really get a comprehensive picture. But what I've done with the time I've had now, there's actually a lot of variation in invertebrate, so shellfish trophic levels too. Because when these large gastropods like lightning whelk and the crown conch, they actually eat other shellfish. They eat other bivalves, so they're higher on the food chain. So what I was looking for, I was looking to see if this trophic level phenomenon, this shift down in trophic level, held, or is this going to hold up with my predicted sort of response to resource stress, and it doesn't change at all. So pretty much what I have is this general size increase in crown conch, and I was trying to make sense of what it is by looking at environment. So sort of in response to Cheryl Clausen and her criticism that, okay, any change you see is probably more likely an environmental one than a human one. These are sort of the broad, basic environmental trends that we know about. And it's been pre-Columbian history in Southwest Florida. There's a lot of environmental variation, not just the big ones that we see, like the change from the Ice Age. There are a lot of little ice ages, periods of warming and cooling, sporadic, periods of environmental change. So this is something I wanted to look at. So you have the Roman warming period, which if we line it up with the phasing correlations, the warming period sort of corresponds to the phase 1 and a little bit of the phase 2 occupation at Crystal River, and then the Vandal minimum encompasses the majority of the occupation at Crystal River, spanning from sort of phase 2 on up to phase 4, and the Vandal minimum was a cooling event. And this, after doing some research, this has a detrimental effect on crown conch size. So I would expect that not only if humans are harvesting them more intensively, they're going to get smaller, but also during this later time period of cooling, I would also expect that the crown conch would get smaller. But that's not what I found at all. So it's the same thing with oyster. And what I found on doing some research is that crown conch are much larger on oyster reefs than they are existing just in the salt marsh. You can collect them sort of generalized hanging out in the salt marsh, but they really like to live on these oyster reefs because they eat the oysters, right? So what we know is that during phase 2, in a later time period, that's when the monumental architecture is starting to be built, right? That's when these huge shell monuments are being built. So my conclusion with at least this pattern in the data is that this is a time period where people started targeting oyster reefs for mountain construction, right? So there's sort of generalized collection just to live in phase 1, which is why we don't see a size, which is why we see lower size in the crown conch. But as they're targeting more they're targeting reefs for these sort of social monuments and things like that. This sort of, to me, kind of explains a part of the big jump and the unexpected jump in crown conch size through time. So what this says to me is that it leads further to the argument that people's patterns of resource exploitation and things like this can't be necessarily predicted, assumed on sort of energetic efficiency only for getting food. You have to account for things like social targeting, social institutions that encourage the sort of harvesting of shell, and for the construction of shell monuments. So this is sort of something that we can use to add another aspect to sort of the human choice part of harvesting. Not that they're necessarily responding to an environment just for food, but they're creating things just for sort of social interaction and symbolic importance. So I think that's a important component to the research. So I guess I already ran through that. Another thing that I'm also working on right now, I'm working on a collaborative project with a few people in the geosciences over at USF, and what we're doing right now is we're trying to get some analyzed oyster isotopes to see if we can sort of reconstruct the health of the ecosystem through time, to see, because these ecosystems are a lot different in a lot of ways than ours, because they're not subject to the pumping of excess nutrients like eutrophication that we have today. So I want to know how easily susceptible were these ecosystems to impact, and sort of how is that different from modern ecosystems today, so they can provide sort of a baseline for ecosystems restoration in the local area, Crystal River right now, but also how we can sort of better interpret the collection of, the intensive collection of shell resources and sort of fishing practices in pre-Columbian Florida. So that's what I've got right now. A lot more research is still to go. We could use a lot more environmental data and better environmental resolution, but hopefully that'll come with continued work of graduate students and their theses and things like this. But just got some vertebrate data back, haven't analyzed it yet, so that's got to go in before I get a really comprehensive picture of these things that I want to look at. But the preliminary results to me are at least interesting. So that's it. That's all I've got.
Are there any indications, or does anybody have any idea where Ripley Bowling's records might be?
Yeah, well, actually, we have his collections. They're all